Okay, ladies and gentlemen, welcome to the United States, welcome to Arizona. And I am with the Arizona Mathematics Roadshow and the Physics Factory, and we take mathematics and science all around the state. We really have a bus, and we really travel hundreds of miles. And last year was the first Arizona Science and Technology Festival, and the first day of the first Arizona Science and Technology Festival was at the Arizona Science Center. We brought it in to unload all of our apparatus early in the morning, and then we took it away early in the morning so it wasn't in the way. And when we were at the Arizona Science and Technology Festival, other organizations like the Sea Life Aquarium and amongst our mathematics activities was the creation of geometric shapes, three-dimensional geometric shapes out of balloons. And if we have any time, I actually have some balloons today. We'll see if we have some time.
You do that at dinner.
Oh, yes, absolutely. We will have some hands-on activities. Sometimes these shapes can be very complicated. That's a dodecahedron. Are any of you mathematics teachers, or is everybody a science teacher?
Science teacher.
Okay. I'm sure that in your science classes you probably teach a lot of mathematics. And yeah, my wife is she is a biologist. She teaches oceanography, and in her science class, her students learn a lot of mathematics. Here are some more shapes. This is an icosahedron made by these two young women, and a larger dodecahedron made of plastic pipes.
Excuse me, sir.
Yes.
They do it by yourself? By themselves?
No. This because I had to teach them while they were making it. I said, take this one and put it here, and then for this one here, with the balloons, I gave them instructions. And actually, with the dodecahedron, all I had to do is I said, here are the pieces, put them together, and there's only one way that they could put them together. Now, you notice that the dodecahedron is tall and the children are short. So, the children put together the lower parts, and then, I'm not very tall either, but I have a ladder, and so I complete the top. And also, I'm a professor at the university. I'm on the faculty at the university. Sometimes I have my students come with me and help, and sometimes my students will climb up on the ladder to complete the dodecahedron.
Well, they can bring it back, fix it.
Absolutely. And so sometimes we have our activities outside. Sometimes we have them inside. Cal was talking about, in many communities, the school is the main center of the community. It's the resource. It's the place where the whole community goes for information. And in many schools, they have evening presentations so that entire families can go, parents and children and little children who are too young to go to school, big children who have graduated from school, and they have these events in the evening. This was a science night in Tucson, and so you can see there's my ladder, and and I have an octahedron in the back made of plastic pipe, and here in the foreground is an arch, the hyperbolic cosine arch. People have been making arches for thousands of years using basic knowledge of geometry and physics. The actual science, the mathematics of the arch, had to wait until the development of calculus and the invention of the hyperbolic cosine function. And so here are some students. You can see one of them likes the hyperbolic cosine function and the other one doesn't. And are some of you teaching, when you're teaching physics, are you using calculus in your classes? Yeah. Okay. Yeah. So this is made of it's made of foam, so it's light, and it can be put together, and then it falls over and put together again. And we also have activities with probability. So here is a machine. I'm sure many of you have seen this machine. Do any of you have this machine in your classroom? It's it has some small golf balls, and if you put a golf ball in at the top, then it rolls down, and at each time it hits an obstruction, it rolls to the right or to the left, and with equal probability 1/2, and after many choices, it creates approximately a Gaussian distribution at the bottom. And so you can see that these children, I think the girl is maybe 4 years old and the boy is 2 years old, they are having an early start learning about the Gaussian distribution function. Yes. And then this picture on the right, it's a little bit hard to see what's going on because it's taken in the dark with lights, but this is a pendulum with two parts. It's we can use it in mathematics or in physics, and in mathematics we use this to talk about square roots, because the time it takes to swing back and forth is proportional to the square root of the length of the pendulum. So the short ones swing back and forth quickly, the long ones swing back and forth in a long time. But of course also it illustrates the physics of pendulums. And that's right. We'll everybody can experiment with this later. And then we have other experiments. This not every experiment is successful. In English, we have an expression: when the air comes out of the tire of the bicycle, we say you have a flat tire. But this is really a flat tire. This is this is a very flat tire. Actually, and when the ground is flat, it doesn't work very well. But if you put it on a this is a very good bicycle for the mountains, because then the corners go into the dips. I left out the slide of my son doing the actual work. So this was very much a family project. My son made this thing, and my father was riding on it, and I took the videos.
What's the roadway made of?
The roadway is made of hyperbolic cosine functions. Yes, and I also use this. I use this at the university to teach differential equations. And oh, you mean what physically is it made of?
That would actually, yes.
I gave you a mathematical answer, and yes, the material is the material is 2 by 8. The edges are made of 2 by 8 lumber, and then the tops are masonite, quarter inch masonite, soaked in water and then bent over the.
You did it yourself?
Yeah, that's right. I bent them myself, and so this is my student from the university who made this, and I also have a video here, but you don't need to see the video because you have seen the thing here in real life, and we can experiment with it. We can experiment with it later. And I should mention that when we go to one of these festival events, either at Phoenix or Tucson or in the mountains, we unpack all of these things and set them out, and all day, and anybody who wants to can come and spend as much time with them as they like. Sometimes, if we go straight to a school, Then, sometimes there are hundreds of students and we have limited time, so then I have to give a presentation with people watching instead of participating. But our favorite thing to do is to spend a long time when everybody can spend as much time as they like. Oh, and here is another event. This is a different kind of event. It's also affiliated with the Science and Technology Festival, but this is very old technology. Technology, in fact, developed in the Middle East between 2,000 and 3,000 years ago, which is catapults. And in historical times, of course, they were used in sieges and invasions. That's right. There's actually there are many contests of this kind, and there are many videos. I didn't bring any video of our event, but it's another way to get the community connected. And so I talked about visiting different festivals. We came to a couple of events in Phoenix and several events in Tucson, which is our hometown. And we almost made it to the mountains, except for the snow this year. But we're going to be going up in the fall. But we go lots of other places. Is an elementary school in New Mexico, about 500 miles away, about 700 kilometers. We have a collaboration with the Biosphere. We spend one day a month at the Biosphere and add our science experiments to their things. You went to the Biosphere as a visitor to learn about the science, the research that they're doing, and also yes, that's right, absolutely. Anybody that visits the Biosphere, they explore with our experiments, and you know that at the Biosphere they talk about solar energy and air pressure and water and things. Some of our experiments also are about the same science topics. Yeah. And then this picture is a little bit hard to see, probably because the bus is very small, and it's in the shadow of a very large radio telescope. And have you also visited?
No, it's satellites.
It's these are radio telescopes in New Mexico, and if you saw a movie called Contact, those are the radio telescopes. These are the very large array, and it looks, billions of light years into the universe. And then this is London Bridge, but it's not like we visited London. But about 50 years ago, the city of London sold the bridge from London to a person that lived in Arizona. And so now London Bridge is in Arizona. It's a town called Lake Havasu City.
Oh, I know.
And from Phoenix, if you travel straight west for maybe 200 or 300 miles or kilometers, then you will get to, well, what you will really get to is the Colorado River. And at the place where this city is, they put a dam in the river, and then the river spread out and made this lake. So it's not a natural historical lake that's been there for a long time. It's a recent lake, and then when they had the lake, then they put the bridge over part of the lake.
The bridge is extracted from London.
Yes,
Transplanted in Arizona.
absolutely. And all the story of London Bridge is a story in itself. All the pieces were carefully numbered and put in place, and then when they brought it over, they put them right back.
The bridge is in London.
We also take part in other activities. In our calendar, the date March 14th is sometimes written 314, and that's also the first digits in the number pi, and so mathematicians love the date 314, and so on this occasion we got a big banner with a few of the digits of the number pi. And then, on a subsequent occasion, we went and helped out at a chess festival. And this was a chess festival just for girls, because the people that organized it wanted to encourage young women to keep studying mathematics and science and intellectually challenging activities like that. And so they had a special chess tournament just for girls. And one day they were opening a new swimming pool in Tucson, and they wanted to have a little bit of educational activities. So we turned up there, and then this one is not. Yes, this isn't exactly a swimming pool, but it occasionally rains, even in Phoenix and Tucson, and when it rains in Phoenix and Tucson, there's a large amount of water in a short time, and all the streets get flooded. And so this is not a scientific activity at all, but it's. I beg your pardon?
Do advertisement for the bus.
It's a little bit of an advertisement for the bus, and it's also information about Arizona. It rains here occasionally, and the young lady on this side is my wife, and that's her friend. Okay, and that's the. This is pretty much the end of my presentation. I have time for questions and all kinds of things. So as you can see, but I will summarize by saying that having a mobile program, we can travel to a lot of places and meet a lot of people that otherwise we wouldn't be able to. But through the festival, and if you have a festival in your hometown or country, you can magnify the effect enormously, because the festivals bring many, many people together. They bring people from the public and the schools, and they also bring together many different kinds of scientists and educators. And so from my point of view, the people, Jeremy and his collaborators at the festival, are stars. And so here's this is the same octahedron that we had earlier, but now it's got stars because we had it at a nighttime art festival. Okay, so thank you.